Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we will try to get to as many as we can near the end of today's webinar. We also have 2 polling questions during the webinar, so hopefully we can get everybody involved in those. And at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Zero Trust Network Security for Containers and Kubernetes. Our speaker today is Pavan Shankar, who is Director of Security Product Marketing at Sysdig. Pavan, thank you so much for joining me today. Really appreciate it.
Thanks for having me, Charlene. Really appreciate being here.
All right, well, I know you have, yes, go right ahead. I'm going to put myself on mute.
Great. So welcome, everybody. Today, we'll have a great topic to talk about, which is Zero Trust Network Security for Containers and Kubernetes. And on the agenda today, we'll cover a few key items. The first, we'll start at the high level of talking about why you need a secure DevOps approach as you are deploying containers and Kubernetes in production. Then we'll zoom into the Zero Trust Network Security, understand why we need that as we are thinking about new security models in Kubernetes. We'll cover some other additional use cases that you must consider as you embed security into DevOps. And then we'll cover a demo of Sysdig to show you how we address some of the key use cases, go over a quick overview, and then open it up for Q&A. So that leads us to our first poll question. So Charlene, you can help us here in handling the first question.
All right, the first polling question is on your screen, hopefully. The question is, which team owns the Container Kubernetes Security Initiative at your company? You can choose between DevOps team, Cloud Security team, or shared between DevOps and Cloud Security. Go ahead and make your choice. And while the audience is making its decision, just a quick reminder, folks, anytime during the webinar, if you have a question for Pavan, you can go ahead and use your GoToWebinar control panel. You don't need to wait for the question and answer period to do that. Any time is a good time. All right, guys, we'll go ahead and give you guys about 10 more seconds to make your choice, and then we'll go ahead and close things out. And we'll take a look at the poll results. All right, shutting things down in 3, 2, 1. All right, and here are our poll results. Looks like for the majority of organizations here, it's a shared responsibility.
Yeah, this is fantastic. I think this falls in line with what we're seeing in the market and talking to customers, that it is really shared. And then the next team that is involved is usually the DevOps team. So makes a lot of sense.
All right, well, I'll go ahead and hide these results.
Perfect. So moving right along. So as we kind of saw just in the poll, that DevOps and teams are definitely one of the primary teams that are responsible for security. So when we step back and think about why must they prioritize security, one of the things that we've been finding by observing customer usage patterns, historically, we found some interesting insights as it pertains to security. The first one is that vulnerabilities in third-party libraries are often being overlooked. So where you might be scanning for vulnerabilities in your OS packages, a lot of times developers are not really looking for those vulnerabilities in non-OS packages like Python pip, Java jar, and others, where about 53% of those non-OS packages have high to critical CVE. So really making sure that you're scanning for not just OS, but also non-OS vulnerabilities early in the process in your CI/CD pipeline, in your registries, and so on. The second thing that we've noticed is that misconfigurations are common, especially as you are running containers in production. A lot of times it's common to run these containers as root, and this is sometimes a bad practice because it can open up more privileges to that container, allowing for that container to break out, for an attacker to break out of that container, and other privilege escalation attempts. So really being mindful of what's running and how privileged containers are in your environment is important to have a handle on and detect for. So really the importance of runtime security becomes prevalent to detect these sorts of misconfigurations and anomalous activity. And finally, there's no record for these container breaches, where last year in 2019, in our annual container usage report, we found that on average, containers live for about 5 minutes, which means that doing things like incident response, forensics, is really important because these containers are ephemeral, and if an attacker gets access into them and exfiltrates data, you want to be able to have a full audit trail of exactly what occurred. So incident response is starting to become an important requirement as cloud teams and security teams are thinking about container security. Now, what we also are realizing is that the landscape of security is changing. If we think about Kubernetes for a moment, right, Kubernetes is really based on an open standards approach, really helping DevOps teams accelerate innovation and drive standardization on a set of community-vetted standards. And when we think about security, typically we've always thought about it as proprietary security solutions, but why must that be the case as we move forward in Kubernetes and into the future, where we believe that the future of security is open, where tools like Anchor engine for vulnerabilities, vulnerability analysis, OPA for policy management, Falco for threat detection, Envoy, Istio, service meshes, Sysdig open source. All of these are open source based tools that allow you to have the security keep up with the development pace as you're deploying apps. Falco is a great example where Sysdig created Falco and donated that to the CNCF, and now that's an incubation project and has really become the open standard for runtime threat detection. And then the open source Sysdig is what many teams and engineers use to get that deep visibility into their containers through the Linux system calls, and it's becoming the standard for container forensics. So all of these different security tools that are open source are coming together to really build this security stack based on an open standards approach, and that's vetted by the community. So as we think about running in production and running with confidence, what are some of the use cases your cloud teams and security teams need to address to feel confident about deploying and scaling up with Kubernetes, right? So as we think about this life cycle, the first phase is securing your build pipeline, where really the use case there is scanning your container images for vulnerabilities and misconfigurations early. So really the concept of shift left. Then at runtime, you want to make sure that you're protected at runtime for across your containers and your cloud environment, where you have runtime security and kind of IDS and detection for container workloads. You have network segmentation, network security in place. You have the capability of doing threat detection in the cloud. So really ensuring that anomalous activity in your AWS accounts and services is something that you are able to have visibility into and detect and respond to immediately, as well as some of the more monitoring use cases around monitoring your containers and Kubernetes environments for their health and performance, and also monitoring different cloud services as well. And then lastly, an important aspect, we touched on this in the usage report, where containers are ephemeral, so having a framework to do incident response, forensics, and troubleshooting becomes really important. And finally, compliance is something that we've always seen. A lot of times it's a key mandate to meet as teams are moving to the cloud, as they're moving to SaaS, deploying more apps in production. Compliance often is a blocker. So how do you ensure that you're continuously compliant against standards like PCI, NIST, SOC 2, right? All of these. So really, all of these use cases put together in your container security strategy allows you to be more confident deploying to production. And that brings us to our second question. And this is something that Charlene, if you can help.
Yeah, sorry about that. My screen was like, my mouse wasn't working there for me. Yeah, polling question is up on your screen now. The question is, what use cases are you looking to immediately address for container/Kubernetes security? So you can select from image scanning, runtime threat detection, Kubernetes security, network security, or incident response. I'm not sure if image scanning was in there twice for a particular reason. It could have just been a glitch. I'm not quite sure.
That's correct. The second
yeah.
is more compliance. So I think if people that are voting, if they just assume that was a compliance bullet, then it'll just be easy.
Okay. Yeah. So we'll do image scanning and then pretend compliance, and then runtime threat detection, then Kubernetes network security and incident response. So we'll give you guys a couple more seconds to make your choice. And while you are doing it, another quick reminder that we do have, I'm sure we'll be having a time for question and answer period. So if you do have a question for Pavan, go ahead and use that GoToWebinar control panel. And as I said before, we'll get to as many as we can near the end of the webinar today. All right, I'm going to go ahead and close out the poll and we'll take a look at the results. Okay, what use cases are you looking to immediately address for container Kubernetes security? Kubernetes network security is the most popular choice there. So makes a lot of sense in my mind.
Yeah, that's amazing.
Yeah.
You know, that's something that I'm actually frankly a little surprised by. I thought a lot of times we talk to customers, they're looking to immediately address image scanning and compliance, which seem to be the smaller ones here. But that's fascinating, and it's a great segue into the actual topic of this webinar, which is network security. So moving along, let's first kind of understand, you know, why we're thinking about zero trust network security in the first place, and let's define and really understand why do you need it. So when we think about traditional network security in Kubernetes, right, this concept of opening and closing ports based on IPs doesn't make a whole lot of sense. Right? Kubernetes really makes static IPs obsolete, where these IPs can constantly change. You may have perimeter-based defenses in place, and they're great tools, but they do have limited visibility into what's going on inside the perimeter, and they're great to protect the north-south, but they don't really understand what's happening inside Kubernetes. And what happens if an attacker somehow gets access through that perimeter, right? So it's like age-old concept of if they get past your castle defenses, then they have full authority to do what they want. And in the container world, it's if an attacker gets root access into a container, they can exploit other services via these open network policies. A lot of times, teams aren't sure how to set those network policies inside Kubernetes, so a lot of times they're by default open. And if a breach occurs, your firewalls that are at the perimeter won't protect you, right? So really, the goal here is to prevent lateral movement inside the perimeter, and that's where the approach of zero trust makes a whole lot of sense. And as you're migrating to cloud and Kubernetes, right, you can think about these as great catalysts to rethink that security model and apply that zero trust philosophy of, you're not trusting anybody inside the network or outside. So explicitly granting access to those individual containers and workloads and pods in order for them to communicate with one another is this concept that you need to be thinking about. So applying that least privilege, right, which is that concept of explicit access based on the context of the application, based on the application behavior, based on the Kubernetes metadata, allows you to define those really precise microsegmentation policies that can govern exactly what can talk to one another. And by creating that policy, you can prevent that lateral movement. So even if an attacker gets, some sort of shell in a container and exploits a specific web server, and if they try to do a port scan and hit some other open services, it'll be much harder for them to get access via the network because you have enforced the right policies to say only this app can communicate inbound to this other database and nothing else can. So that allows you to have that key model in that segmentation model inside Kubernetes. But when we think about in practicality of applying these models, there's a couple challenges, right? So the main thing that I hear often when I talk to customers is the number one problem is visibility. Right? don't have visibility into what apps and services are communicating with each other before I can even apply these segmentation policies. And Kubernetes makes it hard because a lot of times teams have different views of what's happening inside Kubernetes, and it's hard for them to come together and collaborate on figuring out, okay, what is that accurate least privileged network policy I should apply that prevents that lateral movement. And the problem here is because you have three teams that are operating in silos, right? You have your developers that they sometimes have the application knowledge, they understand the behavior, but they're not the ones that live in Kubernetes, so they don't really understand how to create that network policy. A lot of times, they're not interested, or they just don't have that the bandwidth to learn the domain knowledge for understanding and applying Kubernetes networking policies. On the flip side, you have the platform ops teams, your DevOps teams that are, the cluster operators. These are the teams that are living in the platform. They understand how to, work with Kubernetes and apply those policies, but they don't have the application context, and they don't really know what services are talking to one another. So when I talk to customers, a lot of times they tell me there's a huge back and forth here between these teams, right? Where there's, they create a policy, it goes back to the developer, they have to, apply the context, it's not accurate, it goes back and forth, and security gets involved in making sure are we following the right guidelines, kind of the global policies. So it takes a lot of time for them to get these policies right, which wastes time and potentially exposes them to breaches and threats inside their environment. And the challenge is that and the real goal is you need all of these three teams to be on the same page to create that right network policy. And this visibility then becomes the foundation for teams to apply the right segmentation policies in Kubernetes. So how do we, give you that visibility inside Kubernetes from a networking perspective? So as we talked about, the first step is this visibility. So what you're seeing here is on the left, typically, a Kubernetes cluster might look something like this, where your current communication is just a bunch of containers talking to, a bunch of other containers. Now, what Sysdig does that's unique is it automatically understands those network communications based on the system call events and tags automatically enriches all of that data that we collect with the metadata from Kubernetes. So now we understand exactly what those services and applications are inside Kubernetes and automatically organizes that data for you. And this is unique because in other tools, or if you're doing some sort of network segmentation, you have to today manually group those containers based on those image name, tags, and so on, where we're automatically tagging the containers and mapping the communication based on the Kubernetes language, which ultimately gives you a dynamic topology map that you can see from a Kubernetes lens. Now you can basically see, okay, all this traffic communication between a deployment talking to a service that's talking to a stateful set. Really seeing it from a Kubernetes lens allows your DevOps teams to understand and apply the policy that you can enforce inside Kubernetes. So this visibility then becomes that foundation for the strong network security in Kubernetes that you can apply. So as we think a little bit about this visibility, right, you can start with this traffic communication saying, okay, from a physical standpoint, it's a Nginx process on this IP that's talking over port 8080 to this unknown process, right? And we take that specific network event and then give you more context around it that you can understand from a logical standpoint, saying this deployment part of this app via this service is talking to the stateful set that is tied to a MySQL database. All of this is part of this Java application namespace. And then further, you can take it even a step back and say, now I understand that physical communication, but from a logical standpoint, but also what else is that deployment talking to, right? So now you can see that overall there is an external IP 8.8.8. This is a DNS server talking over port 8080 to this deployment that's also talking to these three other services, other deployments, and that one stateful set communication is one part of that flow, right? So you can see here we went from a physical view to a logical view all the way to a full service topology map. This is all dynamically done inside Kubernetes. Then the next question becomes, how do you enforce that network segmentation? So once you have this visibility, the next step becomes, how do I apply those least privilege network policies inside Kubernetes? And then when we think about the approaches today, a lot of times there are container security tools that are out there that are based on a more proprietary approach, where these tools take more of an inline approach rather than being Kubernetes native. So what that means is these are external tools that are tampering with the Kubernetes infrastructure and modifying the IP tables directly, rather than Kubernetes doing the enforcement. Now the problem here is two reasons, right? One, these are external proprietary tools, and we talked about earlier where we believe that the future of security is becoming open, where these tools are not following that open standards approach, and it's something that's doesn't line up with the philosophy of Kubernetes itself. The second reason is these are black boxes, so you really don't have an idea of how these policies are being created and what they're doing. So if the tool were to go down, it could potentially disrupt the cluster itself. So there's a performance impact, reliability issues, and overall security concerns by giving that much permission to an external tool to handle this kind of enforcement. And the better approach here is to think about using the native tools that already exist inside Kubernetes that build upon the philosophy of let the Kubernetes platform itself handle segmentation. So how do we, and this is our approach, where we believe the native segmentation policies is the right way. So when we think about how we apply this, the first step again is the visibility. We covered this earlier, where you have your current cluster, we observe the traffic, we automatically enrich it with the Kubernetes metadata to give you this dynamic network topology map. The second thing that we do is baseline this network policy for you, the Kubernetes network policy, and allow your developer to use a simple UI to refine the network policy and apply the application knowledge that they know. So you can understand that, okay, network policies have an ingress and egress components to it. So I just want to make sure that on ingress, I allow this service to talk to this database. Or if it's this specific service that I'm applying this policy for, it's at the end of the chain, then I want to block all egress from that service. So just making it easier for the developer, not have to modify and refine it by going into the network policy YAML and making those changes. They get a simple UI to just whitelist and allow what they think should be necessary. Then this goes over to the DevOps team, and they say, okay, you've defined this policy, Mr. Developer. Now I can overall see if this policy makes sense for the service, for the namespace, confirm these policy changes, and apply this and sign off on this policy. So you can see that there's immediate collaboration here between the developer, DevOps, and the overall security teams that are providing guidelines. And then the actual enforcement is not via an external tool. It's via the native mechanisms of Kubernetes. So it automatically goes through via CNI like Calico, for example, where Calico directly goes and applies a network policy for you. All we're doing is automatically generating this network policy YAML, which you can just copy and then enforce onto your cluster. So this saves you a lot of time for you to go between going back and forth with the developer, creating a network policy from scratch, potentially fat fingering or messing up some policy. All of those kinds of areas we can help cover and save you time in implementing these policies. And when we talk to customers, a lot of times they tell us that it takes weeks, if not longer, to come up with these right network policies, because a lot of times people are not confident, or they're not sure if something breaks the application functionality or is too permissive on the other end. So by doing this mechanism, it cuts the time down to create the network policy from weeks to a couple hours, which can save you a lot of time as you scale up in Kubernetes and making sure that you have the right network security policies in place. So coming back to the benefits of this zero trust network security, first is visibility. So you get to visualize all your network traffic in Kubernetes, and you can illuminate all those blind spots with these dynamic topology maps, right? Kubernetes can make it hard with all the different controls and constructs, but you can now see your network traffic and your application and service communication from a service lens, deployment, a daemon set, a replica set, all those different environment constructs, as well as seeing it for a specific cluster or namespace. And then you can save time with automated network policies. So by generating it from, helps you not created from scratch. And also the second step is not just creation, it's the modification, right? So ongoing maintenance as your application makeup changes. You want to have a simple, easy interface for your developer to apply those policies rather than them having to muck around in the YAML. And finally, a Kubernetes native approach, rather than using the proprietary tools, gives you more confidence that your platform is secure and stable, and you can have better performance and security by using the native controls inside Kubernetes. So now that we've covered network security in detail, let's step back for a minute and think about what are some of the other use cases that are also important as you are thinking about deploying containers in production. So the first one is, if you shift all the way back, is image scanning, where you want to make sure that you're automating image scanning early in the process. One of the things that we provide is both pre-deployment and runtime scanning. So this is important, where we can scan your images wherever they are, right? So if you're in the build phase, integrating directly into your CI/CD pipeline. So if you're using Jenkins, GitLab, Bamboo, we can scan images as they're built. If they're in the registry, any Docker V2 compatible registry, Quay, Artifactory, ECR, we can scan those images there as well. If you're in Kubernetes and using controls, like using resources like admission controllers, we can actually integrate with them and prevent the deployment of any image that's risky, that doesn't meet those policies. This is important because your developer in practice might bypass the pipeline and in a hurry need to deploy directly on the cluster. But now with an admission controller, that acts as a gatekeeper and prevents that risky image from being deployed if it doesn't meet the criteria that you define from a security, compliance, and governance perspective. And finally, at runtime, this is important as well, where you want to continuously evaluate the running image on the node, making sure that it meets those policies, because new CVs might come up or some zero-day vulnerability might pop up that might compromise you. And even though you might have scanned early, you still are vulnerable at runtime. So ensuring that you're continuously scanning and making sure you can prevent and detect these vulnerabilities early is something that we provide. And one of the unique things with Sysdig's image scanning is we offer what we call inline scanning, which is basically scanning directly in the pipeline or in the registry or on the node, where the scanning happens locally and only the metadata about the scan results gets shipped back to Sysdig. So this helps you because you have full control of your images. You don't have to share registry credentials or send your image to a staging repo. You have full control of your data, your PII data, where the only thing that gets sent back to Sysdig is the metadata and the results. And that's the central place where you can define those scanning policies, but have full control that and full confidence that your images and your scanning happens in your environment only. And from a vulnerability standpoint, we use the open source Anchor engine for vulnerabilities, and we have also added MullenDB as an additional source for non-OS package vulnerability scanning. So once we tackled compliance, the second thing to incorporate into your container security framework is a mechanism to validate compliance continuously. So this is the ability to be able to make sure that you're able to have meet compliance standards across the entire container lifecycle. So a good practice here: start with those CI benchmarks to validate the cluster configuration, but then also make sure you're scanning for controls for PCI, NIST, right? SOC 2 as part of your image scanning workflow. So making those scanning policies map to compliance controls early is a great way to shift compliance left, but then also validate compliance at runtime. And we have all of these runtime rules based on Falco that are already mapped to the different compliance standards like NIST 853, 800-190, SOC 2, PCI, and so on. So that gives you confidence that you can validate compliance at runtime as well. And finally, the last part of the lifecycle, the response phase. So let's say something does occur in a sensitive PCI scope namespace. You want to have a full audit trail of exactly what occurred, all the commands, connections, file activity, user activity. That proof of compliance is great for an auditor to see and ascertain whether you did or did not meet compliance. Then the next step as we tug along is runtime security. So we talked a bit about Falco here. So let's start with Falco, where Falco is part of CNCF. It's the open source standard for runtime security. And the way Falco works is, you can deploy the Falco agent as a daemon set in Kubernetes, as a privileged container, root process, and it hooks into the kernel and has visibility into all the system calls that it collects via the kernel. It also integrates with the Kubernetes audit logs as another rich source of detection. So you can think about sort of the Kubernetes control plane detection coverage via the audit logs that goes into Falco, and then the system calls that gives you full visibility into what's happening, at the host level. And then you can build your DIY responses on top, and use Falco to alert on malicious events and abnormal activity happening at the workload level. What Sysdig Secure does is really build the runtime security around the Falco engine. So the same mechanism of syscalls and audit logs, but now you're sending all these events and security events back to the Sysdig platform, where it's automatically enriched with the Kubernetes metadata, the cloud provider, context, all the other context surrounding the environment, and then it provides out-of-the-box policies. So policies that you can apply that are based on Falco, but automatically apply them into your environment. They're all pre-configured for you and mapped to the various standards like MITRE, tech framework, compliance standards, file integrity monitoring. So just you have out-of-the-box default policies at runtime to apply and make sure that you're detecting for those incidents. You also have automatic remediation. You can stop a container, pause a container if something does happen that you define as anomalous, and then alerting on those events by plugging into tools like PagerDuty, Slack, VictorOps, right, SNS, really wherever your DevOps teams are and your security teams are, you can alert them immediately. And finally, forwarding these events just to SIM tools. So your SOC teams are also benefited by having a response framework in place for these container security events, where they can see exactly in Splunk that these events have occurred and analyze them directly there and then investigate further. And then finally, the Kubernetes native mechanism. So we talked about network security. That's one mechanism, but we also apply threat prevention using pod security policies in Kubernetes, and a similar mechanism there where we can auto-generate a pod spec, PSP based on a pod spec, and then validate that PSP before you apply to production. So you have full confidence that you have a least privileged workload being deployed that meets those specific requirements, that your pod is not running as root, it only has read-only access, right? Making sure seccomp and AppArmor are enabled, all of those configuration checks, preventing some sort of malicious activity that might happen if your pod configuration is exposed and that pod is compromised. So we talked about audit logs. This is another really important aspect. What we're seeing from customers, really leveraging the audit logs as another rich source of detection. We talked a lot about the system calls. This is the other aspect as well, where you have users and workloads making API calls to Kubernetes. All of these interactions are getting logged in the Kubernetes audit logs. All these interactions with the API server, and what we're doing is automatically ingesting these activity logs into a Sysdig agent and allowing you to write detection rules based on the events that we're seeing in the audit logs. So examples here are, did someone store credentials in a config map versus secrets, right? You can detect on that. If someone execing into a pod, is a user escalating privilege via RBAC. So really all the control plane detection rules, you can now have a mechanism in place to detect on all of those as well. And again, all these events are sent to a Sysdig platform where you have full visibility, context to investigate and analyze everything from the user all the way down to the system activity. So you can take a, kubectl exec session, see who logged into the pod from which IP, and see exactly the commands that they ran, connections that they made, what files did they touch. That full audit log, even after this container is gone, is hugely important and valuable from a compliance standpoint and just overall security framework. And as we expand a little bit into the same mechanism of monitoring the activity, we also want to think about what do you have in place from a cloud perspective and detecting threats in the cloud. So for AWS specifically, you have sources of data like CloudTrail, which you may have a ton of different services performing API calls on a growing list of AWS services like RDS, EC2, S3, and so on. All of these events can potentially get recorded in CloudTrail if you turn on CloudTrail. And those events can be sent to S3, from which we can ingest those CloudTrail logs and apply the Falco detection rules against these CloudTrail events to detect if an S3 bucket is publicly exposed, have permissions been turned off, right? Or if a load balancer that's publicly facing is launched, or an IAM user, role gets changed. All these account and service activity that's happening inside your cloud is also something that you can detect on using Sysdig Secure. That's really leveraging the Falco engine under the hood. So again, these events can be forwarded to Security Hub, CloudWatch, as well as Sysdig Secure. So now you have a single security platform that allows you to have a unified policy interface to define policies across containers, Kubernetes, hosts, and cloud services. And finally, once you have this runtime threat detection mechanism in place for your containers, Kubernetes environment, as well as your AWS cloud services, you want to have a response mechanism in place and the ability to really conduct incident response and forensics. And what we provide here is the ability to have a full detailed record, have the activity, all the activity logged, the ability to capture all those events before and after, and have full forensics evidence even after that container is long gone. So we'll show you this in the demo, but this is really important and really valuable for those customers that are trying to make sure that they can respond to events when they do occur and have a proper framework for incident response and forensics. And finally, you also have this ability, as we talk about investigation and connecting it back to the network, you have this ability to investigate all the process level investigation, where if a process makes a connection that's either successful or failed, you can see exactly what that connection was and all the surrounding context about the namespace, the container, the host, all the other connection events, all directly in Splunk. So there's a Splunk app that we provide that allows you to audit and investigate all these different connections made to and from the process, identify top talkers, spot some sort of packet manipulation attempt inside your environment. And then when we think about customer example here, Goldman is a great example of an incident response, applying an incident response mechanism where initially they had a visibility problem. They couldn't see inside their container environments, and they wanted the ability to map those connections between services and applications. We first provided those topology maps that allowed them to see all the network traffic from different lenses of choice, from a Kubernetes lens, a container workload, host. And then the runtime threat detection with Falco really allowed them to apply those MITRE attack framework policies, detect on those incidents, and then really help their SOC team respond faster to say, this event occurred in their SOC. This was tied to a lateral movement or a privilege escalation or credential compromise, and then allow their SOC team, even though they didn't speak the language of Kubernetes, understand the severity because it was mapped to a known security framework. So really helping the collaboration between the DevOps teams and the security teams by bridging the gap between those two teams. Great. So now we have about 10 to 15 minutes. I'm going to jump over to the demo and show you the product in action. So first, we talked a lot about network security. So I'll start there, where this is our latest release as part of our launch that we launched this week with Zero Trust Network Security. So this feature is available for all our customers. And as you see, network security here, the first thing is to really understand how to apply these network policies and see where you want that visibility. So the first thing you can do is actually select a specific cluster in Kubernetes. You can select, AWS. I'm going to select a Google GKE cluster here. And then now I can drill into the specific application or namespace. So you can see Sysdig automatically organizes all that information by cluster and a namespace lens. So now I can click that SOC shop application and see all of this in context. So the first thing I want to understand is a topology into my namespace to get that visibility that we talked about, right, between the applications and services. And again, you see this dynamic topology map that I can organize by a 3-hour lens, 12 hours, 1 day, or 7 days. So a lot of times when I talk to customers, they want to see different time periods where what was the connection a week ago versus now. So we allow you to do that. And then also you can slice this from any lens of choice in Kubernetes. So you can see it from a service, you can see it from a deployment, you can see it from a stateful set. But for this example, let's go back into service. And let's say the sock shop application is a application that's a retail application where you're selling socks on your website, and you have all these different microservices. So you have Carts DB where you can jump into, which now you can immediately see what the network traffic looks like for this. And this might be an external facing app, right, where this is dealing with a lot of external traffic. So you really want to have a robust and least privileged network policy in place. And here you can see that this deployment is talking to, over this 27017 MongoDB port to this specific application. So first I get this visibility. And the next step is to say, do I want to whitelist the specific policies and apply the network segmentation? Right now, everything was allowed. So I can actually go into these tabs here and these tables and then apply the least privilege here, where I can actually start and say, block all ingress. Maybe this is, a specific service that needs to be blocked off, so you can block all ingress, or allow all ingress inside a namespace, and then, or I can whitelist and just select the specific namespace and pod that needs to be talking for the specific service. So I've allowed this, and then I can also allow specific CIDRs and IPs here. So I can say allow all ingress from this specific range of IPs, or make sure that certain IP subnets are blocked as well. And then on the egress side, similar mechanism where you can, if this is the service at the end of the chain, you want to maybe block all egress and apply that policy there. So you can see with these tables, it's really easy to apply the network policy without having to work through a YAML file. But once you select these policies in place, we actually generate the YAML for you. So you can see here, automatically we generate that YAML, the network policy here, where it's, all I need to do now is just download this YAML file and apply this onto my cluster, and via a CNI like Calico, this is generated for me. And then now I can go into the topology here and see that this specific connection that I just disallowed is now blocked. So the red line here, you see, we had two different connections that were initially coming in to this deployment via the service. Now one of them is blocked. So you can see that it's way easier to just use these a simple UI to make those changes. So on an ongoing perspective, your developer can refine and continue to apply the application knowledge and the behavior to define these network policies that are least privileged and segmented based on what you define as the right security policy. And then as we step out of this, there's many of the use cases that we talked about. So just quickly covering those outside of the network security. I'll first jump into the overview page here. What this gives you is a macro level view of exactly what's happening across both build and runtime. So again, the same mechanism of being able to slice your data from any lens, where I'm seeing this at a macro level, but I can pick a specific cluster and then go again into the same sock shop just for consistency's sake, and see all of my image scan results, whether they're in the registry, whether they're currently running, their images that are passing or failing, CVEs by different severity levels, all of this in context of this specific namespace. So it just makes it very easy for me to zoom in to a specific application or service, and then now understand, okay, there are a couple of images that are failing that are currently running in this namespace. There's 19 images, 21 are passing. And if I jump into one of these images here, I can see exactly the policies that were triggered, the vulnerabilities inside those images, inside the specific image, both at an OS level and a non-OS level. If it does exist here, in this specific image, it doesn't, but you can see vulnerabilities for Java jar, Python pip, all of those and sort them by critical and high and other severity levels to make it easy to understand exactly what the vulnerability is there a fix available, and then who owns that fix and who needs to fix it. The other mechanism to make sure that you have from a scanning perspective is ensuring you can scan your images early in the process. So in your CI/CD pipeline, where we provide out-of-the-box policies for Docker file best practices, compliance standards like NIST and PCI, and allow you to define a lot of different flexible rules based on vulnerabilities in your OS and non-OS packages, where you can say make sure that no image with a OS package with a high severity CVE that has a fix available is running longer than 30 days. It should not pass my build, so stop the builds that exist. You can also scan for misconfigurations like running as root or exposed SSH or DNS, embedded AWS secrets, right? Other parameters. So a lot of different policies in place for you to really define your security, compliance, and governance requirements, and how you can embed them and trigger them is really in your pipeline directly. Where if I go into a Jenkins pipeline here, I have this example, but you can integrate with other tools. You can see that in my recent build, this last build has failed, and a Sysdig security report is generated. So your developer immediately sees exactly why their build failed and all the policy changes that were triggered. So that's how you, in a nutshell, with scanning, you have pre-deployment and runtime. Next up is the runtime security. So really all of these policies that are based on Falco that we talked about. If I actually go to rules library, this would be easier, where you can see all the rules that are out of the box for you based on Falco, automatically tagged, based on different compliance standards. So this is runtime compliance for NIST and SOC 2, also other standards like, MITRE attack framework. So if you want to see it by MITRE privilege escalation, all this comes out of the box, just making it easier for you to speak the security and compliance language when you apply runtime policies. And then let's say you want to create a specific policy. It's really simple. This is the runtime policy interface, and you can see here, if I click a policy, for example, like a shell in the container, I can actually click into that specific policy now and see and scope the policy by the environment that I want to define that policy for. And again, you have one unique aspect about Sysdig is you can really create precise policies from using any of the annotations and labels and the Kubernetes and cloud metadata to really make it as precise. And then you can take remediation actions that are automatic, that can kill or stop the container, as well as notify the right teams if this event does occur. And there's a capture file here, and we'll talk about this in just a moment. So let's say I create this policy. Now, if I go into the events tab, here, basically you see a list of all events that have actually occurred in your environment. So across image scanning results, runtime policies. And this is really helpful because you're seeing all events across cloud environments, or cloud trail security, image scan results, other potential events that have happened. If I sort by runtime, you can see all the runtime events. So someone modified credentials, config map, changes, crypto mining, right? That shell in the container that we just saw. So if we just follow that example where, I had created the rule, detect a shell in the container, that actually happened. Now you are actually seeing this event occur. And the thing that we provide here is really unique, where the first thing we give you is all the activity surrounding this incident. So you have a full audit of exactly what happened when the shell in the container launched. And this is unique, where we're the only tool today that allows you to see all of this, the information from a Kubernetes, all the way from a user level in Kubernetes, so who exec into a pod, and all the way down to the command connections and the file activity that happened. So what you're seeing here is the shell in the container in context of all the events in context around that incident. So someone logged in from this IP, curled down this URL, here's the IP, port protocol, right? To tar the file, zipped it, share the bash history. So all of this is kind of the activity surrounding this incident, and really valuable because Kubernetes might kill this container, but you have a full audit trail of exactly what occurred. And you can also use this for more proactive threat hunting, where you want to see and understand exactly what events are occurring in your environment, what kubeexec connections are being made, whether that's routine operation, whether that's a malicious attack, really being on top of your incidents and activity that's happening inside Kubernetes, and really seeing it from any lens. So seeing all this activity by the lens of an AWS environment, a cloud lens, a more physical lens, or a logical lens like a Kubernetes namespace, right? So this is really beautiful and easy for you to understand exactly what's happening from the lens of choice that you want to take. And finally, the last part is the capture file. So we briefly talked about captures, but this is really the cornerstone for doing forensics, where going one step deeper than the activity audit, we can show you all the system calls that happened when this terminal shell occurred. So this is based on a trigger. So if you select this, if the shell in a container happened, we would take a dump of all the system calls pre and post event. So in about 30 seconds, we dumped almost 500,000 system calls. And now you can actually do forensics and incident response, where you can say, okay, when the shell in the container happened, I collected all these system calls. Now I want to see what files were touched, what commands I ran, what connections were made, what were the active network connections, and so on. And now you can see there's a little pattern here. And if I zoom into just that time period to less than a second here, I can actually see this in context of those 35,000 system calls, 33,000, and then actually open up those commands. And again, you see the same commands you saw in Activity Audit, but I can go a step deeper, where I can actually show you exactly the tar file that was, that was launched here, and reconstruct the file for you. So open up this file, this README file in printable ASCII, because I'm collecting all of this via the system calls, recreate the file and show you this to see exactly what happened when the rootkit was installed, and show you all the way down to the file payload level exactly what happened. So this is, extremely useful and really granular, deep visibility and data that you have that serves as a single source of truth for both security incidents, forensics, and troubleshooting and monitoring. Right? So you have the single data source that allows you to address, someone shelled into a container, but also from a different lens, if someone, if an application performance was changing, or there was a crash loop back off in Kubernetes. So really having all the data there from a monitoring standpoint is also something that this is useful for. So that's, in a nutshell, what we just went through was on the runtime side, showing you how to set a policy, explore all the activity around it, and really analyze and go deep into the forensics aspect with the captures. Finally, we also have compliance. Lastly, to give you a dashboard here and a report that tells you for different frameworks what your pass percentage is for the PCI 3.2. You can generate this report across different clusters, and then basically see what are you passing, what are you failing, what are the different checks. It's really an easy way for your DevOps teams to meet the security and compliance requirements. Just lastly here, I want to jump back into the slides. So I'll quickly cover this. We talked about a lot of things in the demo, but just wrapping it up, some of the key areas of why Sysdig is unique. One is we collect this granular data from the kernel that allows us to have full visibility into everything that's happening, and really nothing lies to the kernel. The second reason we talked about a lot, which was the rich context we collected from Kubernetes, the cloud, and really enrich all that granular data so you can see all of that from a service lens, the application view, and really cover that last mile, right? Where you not just you don't want to know that you just have 100 vulnerabilities, but you want to map that back to a specific application or a service, or define those policies with those contexts in place. And then finally, really being built on this open source foundation. We talked about this at the beginning of the talk, where we're built on these open source tools like Anchor Engine for vulnerabilities, extending Prometheus, really extending and building on Falco, and then the Sysdig open source for forensics and troubleshooting, and adding the workflows, the context, the scale on top to allow cloud teams to run confidently in production. And really, the platform is SaaS first, so we're a SaaS first platform that you can deploy in minutes, but we also give you the ability to deploy it on-prem, self-hosted in your own AWS environments, in your cloud environments, and really the tool that's built for DevOps. So integrating into your build phase, into your CI/CD and registries by scanning early in the pipeline, runtime security and visibility into all those applications that are running on top of your containers, your Kubernetes, your OpenShift environments, your Rancher, all of those. And then finally, plugging into the response frameworks. So alerting via tools like PagerDuty, ServiceNow, Slack, and then also forwarding events to Splunk, IBM QRadar, Syslog, and other SIM tools. So you really have a complete platform that addresses all these use cases across the build, run, and respond phases of the lifecycle. And then lastly here, again, we covered this, but built on open source, deep visibility, and then allowing you to scale with Saas and DevOps are the key highlights of our platform. And if this is interesting and you want to learn more, we have the Sysdig blog that has a lot of great content. We just announced our network security launch, so there's a blog on there that you can go into more detail as to how we give you that visibility and security for inside your Kubernetes networks. We also have the ecosystem guides that are available for you. And also, if this was interesting and you want to take Sysdig for a spin, there's a 30-day free trial that you can sign up for, and you can play with the product and see it in action for yourself. Great. Thank you. Hopefully this content was helpful. And now we'll open it up for Q&A.
All right, great. So we are about 4 minutes to the top of the hour, so we don't have a lot of time for questions, but I think we can maybe get to one here. Let's see the question here. Network topology is built using service mesh. If so, which service mesh is it?
So that's a good question. So what we are using, we're not actually addressing service mesh here. We're actually applying network policies, which are more the layer 3, layer 4 controls in Kubernetes. And we're collecting the network connections that we're seeing, enriching it with the Kubernetes context, and building that network policy for you. And we believe this is the first step. And the next step in this evolution is once you get your network policy in that layer 4 accurately defined and segmented, then you can move into the layer 7 with service mesh, which is something that we will cover as well, in the future release.
All right, great. Excuse me. Unfortunately, we don't have any time for additional questions, and I don't think actually we did get well, let's do one other real quick and then we'll close it out. If a Kubernetes is in an infrastructure managed by Istio or Anthos, how is the behavior of Sysdig?
Yeah, so we support Anthos on-prem. So any of the managed services we fully support. So all of these, what we discussed was really for vanilla Kubernetes, but the behavior is consistent and applies in all the managed Kubernetes flavors as well.
Okay. All right, great. Okay, so we have 2 minutes left to the top of the hour. So I'm going to close out the question and answer period. Thank you to those who did submit questions. Also, quick reminder that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following today's event, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars, look in the on demand section, and it should be right there waiting for you. Okay, at the top of the hour, I did mention we'd be doing that drawing for $25 Amazon gift cards. So without further ado, let's go ahead and do that. Our first winner today is Andre L. Congratulations, Andre. Second winner is David C. Congratulations, David. Our third winner today is Marcos O. Congratulations, Marcos. And our final winner today is Francis M. Congratulations, Francis. We will be sending out an email to all of you, all 4 of you, with information on your Amazon gift card. So please check your inbox. If you don't see it there, please check your spam folder. Pavan, thank you so much for a great presentation. Really appreciate it. And I'm always a big fan of the demo, so thanks for including that as well.
Absolutely. Thank you so much for having me.
All right, great. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody, and please stay safe.